Hi everyone, I'm Ava, and today I'm going to give you some historical knowledge. We're going to be diving into the history of calculus. Isaac Newton and Gottfried Leibniz are the two men who created calculus. Newton was an English mathematician and physicist who was world-renowned for many complex theories that became laws, including Newton's laws. He even has a form of measurement named after him, the Newton, which measures force. Leibniz was a German mathematician who was instrumental in the development of the binary system, and he also did research that contributed to the mechanical calculator. They were both pioneers in the field of calculus, but they went about it in different ways and were completely independent of one another during the process. When he first revolutionized calc in 1665 through 1666, Newton thought variables changed over time and used x and y to compute the tangent line of the graphs that he used. Sometime in the middle of the 1670s, Leibniz thought that x and y ranged over infinitely close values. Despite Newton working on it earlier, Leibniz published his findings in 1684, while Newton published in 1693. For Newton, calculus was geometrical in the way that he went about it, but for Leibniz, it was always more analytical. Leibniz was all about the importance of consistent and clear notation, while Newton didn't put any thought into his symbols. He did what he felt like on a particular day. Who has time for integration anyway? Due to Newton's lackadaisical approach and Leibniz's more tactical one, not surprisingly, most of the symbols and notations that we now use can be attributed to Leibniz. A similarity is that both never thought in terms of functions, but always in terms of graphs. Another is that they both use infinitesimal calculus, which will be defined later in this video. Lastly, as previously stated, they both discovered calculus through their own tactics and research. Historically, calculus can be split into three periods: anticipation, development, and rigorization. The first stage is anticipation, and within this period, many processes were used to find areas under curves, and also the maximization of quantities were found. Within the second stage, development, Newton and Leibniz created the foundations of calculus. They brought specific techniques and instances under the main concepts of the derivative and the integral that we all know and use so frequently now. Apparently, their methods weren't always entirely logical, and it took the next stage, rigorization, to justify and to alter them. Rigorization. This is where calculus was found to be sound mathematically, and many mathematicians strive to improve it by their own calculations. While still in development, another mathematician named Lord Bishop Berkeley majorly criticized one of the concepts of Leibniz and Newton, infinitesimals. Infinitesimals were quantities that were infinitely small, but still non-zero. They used these to derive and integrate, as it was simpler than anything else that they used at the time. This is because, as we all know, mathematicians are lazy. 100 years later, the rigorization period took up Berkeley's criticism and established the limit instead. In between now and then, more developments occurred, more fights ensued, and most importantly, more advancements were made to pioneer such an integral component of the way that we live today. For example, calculus is used in economics. It is used to determine the right time of buying and selling products, the marginal value of products, and it can also be used to determine the right time for economics to grow business. Biology is another field. Calculus is used to determine growth rates of bacteria, for population growth, and more. Engineering is the field in which calculus is used most often. One of the many applications in this field is for architects. Armed with calculus, they determine the size and shapes of roads, bridges, and tunnels in order to best fit the needs of people and land that these structures rest upon. There are countless other applications, including vehicle safety, space technology, and even in credit card companies for payments. Who knows? By the time that I'm a working adult, there could be infinitely many more uses for it. And I'm looking forward to seeing that happen. Thanks for watching.